Ever wondered why the Romans were defeated in the Teutoburg forest? What secrets lie buried in prehistoric Ireland? Or what made Alexander truly great? With a subscription to History Hit, you can explore our ancient past alongside the world's leading historians and archaeologists. You'll also unlock hundreds of hours of original documentaries with a brand new release every single week, covering everything from the ancient world to World War II. Just visit historyhit.com/subscribe.
Hello and welcome to our latest Ancients episode. Today we're going to the time of the dinosaurs, but just before that I wanted to do a quick shout out because a couple of weeks ago I got a message from one of our fellow Ancients listeners, Hugo, and it was a video message and it featured Hugo and the youngest listener of the Ancients, 2-month-old Aurelia. Hugo and his wife's newborn daughter. Now, Hugo sent me a wonderful message to let me know about Aurelia and how she's already been delving deep into the Ancients archive, her favourite episodes already being the Permian extinction and the fall of the Sumerians. So Hugo, well done. You've already got Aurelia hooked on global prehistoric catastrophes and the falls of civilizations, so keep it up. Anyways, on to today's episode. We're going back to the age of the dinosaurs to talk through the story of what is, for many of us, our favourite dinosaur, that iconic, plated, armoured dinosaur, Stegosaurus. And to talk through it all, we've got one of the leading experts on armoured dinosaurs, none other than Dr. Susanna Maidment from the Natural History Museum. Now, Susie, she came into our studio, so we filmed it as well. You can watch it on the YouTube channel, also featuring a fluffy Stegosaurus toy, Steggy. It is my own, I must confess, and I really do hope you enjoy. Let's go. Maidment, paleontologist at London's Natural History Museum, which is home to Sophie, one of the most complete Stegosaurus fossil skeletons on display in Europe and indeed the world. Susie, it is great to have you on the show.
Thanks very much for having me. It's a pleasure to be here.
And we're talking about Stegosaurus today, and this feels like, for so many people, it is their favourite dinosaur. It is iconic today.
It absolutely is. And, every 7-year-old knows what Stegosaurus is. And, I give talks about Stegosaurus and I ask in the audience first, who's heard of Stegosaurus? Because this talk's going to go badly if you don't know what I'm talking about, right? And, almost everyone puts their hand up. Everyone knows what Stegosaurus is.
I guess we're quite fortunate to be in the UK with this study of Stegosaurus because we've got one of the best preserved specimens at the Natural History Museum. Is it Sophie?
Yeah, we have the world's most complete Stegosaurus on display at the NHM. But actually, there are also 2 different species of Stegosaur known from the UK, including the first one ever discovered, which was found in Swindon.
In Swindon?
It was.
The Swindon Stegosaurus.
The Swindon Stegosaurus. It's called Dacentrurus armatus. It's one of my favourite dinosaurs, actually. It's on display also in the Natural History Museum, but it's in a kind of a cabinet, like a slab mount, and people just walk past it, they don't notice it, but it's the first Stegosaur ever found anywhere in the world.
Justice for the Swindon Stegosaurus.
Absolutely.
That needs to get more, so maybe we'll talk about it a bit more as this episode goes along. But I feel we need to address this first off. You mentioned the word stegosaurs there. We've already said Stegosaurus, so can you tell us the difference between the 2 words?
Yeah, so Stegosaurus is one type of stegosaur.
Right.
Stegosaurs are a group of dinosaurs. So it's a bit like having antelope as a kind of, group of animals that kind of look the same, evolved from a common ancestor and are quite diverse today. But then there's individual species within that you can recognise. And it's the same with stegosaurs. So we have a whole range of them. They lived all around the world. And of course, Stegosaurus is the one that everybody knows, but there are loads of others actually.
Does it have a particular scientific name?
It's Stegosaurus.
It's just Stegosaurus. Okay, well.
For most dinosaurs, we don't have kind of popular names.
Right.
They are just the names that they're given. But of course, our one at the Natural History Museum, Sophie, has a nickname. But yeah, no, it's Stegosaurus, yeah.
Well, we'll cover stegosaurs at large as well in this chat because it feels like the others, we can shine the spotlight on them at the same time. But when abouts in the age of dinosaurs do stegosaurs live?
Yeah, so they first evolved in the Middle Jurassic. So that's about maybe 167 million years ago, something like that. Okay. And they really get going in the late Jurassic. So that's when they're most diverse and we know the most different types of stegosaur from. And then they really decline after that and actually go totally extinct by the end of the early Cretaceous about 100 million years ago.
Okay, so what types of dinosaurs should we be imagining living alongside them? Because sometimes you'll see pictures of a Stegosaurus defending against a Tyrannosaurus Rex or something like that, but that feels like a misnomer.
Yeah, it's a really common, misconception that all the dinosaurs were kind of, mooching along together in the same ecosystem. And actually, of course, they weren't at all. I mean, aside from the fact they're living on different continents, although Stegosaurus and T-Rex did live on the same continent, they were actually separated in time by millions of years. So Stegosaurus was already a fossil when T-Rex lived. T-Rex lived 66 million years ago. Stegosaurus lived 150 million years ago. So T-Rex is actually closer to us in time than it is to Stegosaurus.
You stole the line exactly. I love that fact, the fact that T-Rex lives closer to us than Stegosaurus does. Okay, well, you mentioned location in the world. Where do Stegosauruses live in the Jurassic, in the world as it looks like at that time?
Yeah, at that time. So we've really got two continents. We've got a northern continent which is called Laurasia and a southern continent that's called Gondwana.
This is just after Pangaea's split up at the end of the Triassic.
That's right. And so we've got a big seaway between the two, but the Atlantic's only just beginning to open. So there is some separation between North America and Europe, but they're not fully separated. There's probably still kind of routes across through Greenland and the top up there. And so we have stegosaurs living in North America, in the west, what is now the Western US, most famously, of course, things like Stegosaurus. But then we have stegosaurs all across Europe. We have tons of stegosaurs in China. We've got them in Africa and South America as well. So in fact, the only continents where we don't have stegosaurs at the moment are Australia and Antarctica. And I reckon they were probably there. It's just that we haven't got a really good sample of the fossil record from those continents yet.
Do we have many fossil sites for stegosaurs surviving? Of all the dinosaur species, are we quite blessed when it comes to stegosaurs?
Yeah, no, not really, actually.
Okay.
They're, despite the fact they're very iconic and very well known, they're actually really quite rare as fossils. Now, Stegosaurus in North America is relatively well known, although we don't have very many complete animals. In fact, almost no complete skeletons at all. We do find lots of evidence that they were living there. They're much rarer at other times and in other places, so much less common. I mean, we only have a couple from Europe, for example, and they're quite common in China, but China's a massive place with a long rock record, so yeah.
And also, last question before we delve into, I guess, head to tail of a Stegosaurus. We mentioned already how like T-Rex is not living alongside Stegosaurus, but in this period, like the late Jurassic, let's say, what are the key dinosaurs that would have been living alongside a Stegosaurus?
The other dinosaurs that we see are long-necked, long-tailed dinosaurs primarily. So these are things like Diplodocus and Brontosaurus and Brachiosaurus and
the
sort
giants.
Of the giants that you're very familiar with from, when you're a kid, basically. And these, again, are all living in the Western US alongside Stegosaurus. In fact, I think currently there's about 26 different types, different species of these sauropod, long-necked, long-tailed dinosaurs living alongside Stegosaurus. So they were the real kind of dominant herbivores in these ecosystems. Stegosaurs seem to be, slightly more rare, not quite as common. And then we have predators, things like Allosaurus in North America, that are very well known from that time period. And it's really interesting because then we go into the Cretaceous period. So, and these ecosystems completely change. And we don't have stegosaur and sauropod dominated ecosystems anymore. That herbivorous kind of niche, it changes, and we get ankylosaurs and iguanodontian dinosaurs occupying that instead.
And also that shift from Jurassic to Cretaceous, it's not like a big world-ending cataclysm event that marks that shift, is it?
Well, no, there's a faunal turnover. So the animals that characterize the ecosystems change. And this is what early geologists and paleontologists recognized. This is why they drew that line, because they recognized that both in the sea, in the marine realm, and on land, we actually see a kind of turnover of animals. But what caused that turnover is a little bit unclear. And some people have suggested there might have been some sort of extinction event, but it's not really clear what might have caused it and whether this was true everywhere.
And stegosaurs are one of those creatures that do die out with the turning of that, with that ecological change, or gradually decline.
Yeah, well, it's a bit weird because in North America, we don't see any evidence of stegosaurs after the Jurassic. And we do have good terrestrial ecosystems from the Cretaceous. We have good Cretaceous rocks, good fossil records. So if they were there, we would have found them, I think. In the rest, in Europe and Asia, we actually do see the stegosaurs continuing into the Cretaceous, although they're much more minor, they're quite rare part of ecosystems.
Are these lush tropical habitats that they're living in? Do we know much about the ecosystems of the Jurassic that they existed in?
Yeah, in North America, we're looking at probably seasonally arid environment, bit variable because actually they, the whole of the North American continent's big area. The area where they were living actually is, covers 12 degrees of latitude. And in the north, it was probably a bit wetter. And then in the south, it might have been quite arid. But yeah, probably seasonally arid, seasonally wet. And Probably similar elsewhere. In Europe at this time, we actually have mostly marine rocks. So the stegosaurs that we're finding were probably kind of floating and bloating. So the animals are being washed out into the sea, and their carcasses are floating out, and then they're eventually falling to the sea floor. So we don't really know the environments on land very clearly at that time in the UK, for example.
So some stegosaurs have been found at the bottom of Jurassic seaways, I guess, then. Wow.
There's a super cool specimen in the Natural History Museum. It's one of my favourite specimens. I always show it to visitors to the collection. It's not on display, but it's a couple of stegosaur tail spikes. So I'm sure we'll come to them.
We'll get to that, yes.
And it's actually got bivalves, so, two shellfish actually encrusted on it. So like today, when you have whale falls, and animals kind of, it forms a little ecosystem. The whale skeleton forms a little ecosystem with things living off the bones. It looks like the same was happening with this stegosaur skeleton way back in the late Jurassic.
Okay, so no wild theories that this particular type of stegosaur became a marine animal, could swim.
I don't think it was swimming, but to be fair, all we know of it is its two tail spikes. There's nothing else. So, I can't rule it out.
Who knows? But it sounds like the general characteristics of a stegosaur, you can identify it, whether it's in North America or the fossils are in China today. But because the ecosystems, differ in those areas, you can notice, how the species had unique little characteristics that differed them between other ones depending on where they lived.
Exactly.
And so if we focus on, the overarching features of a stegosaur, and then we can delve into kind of little details and how they change. If we go from head to tail, let's start with the head. What should we be thinking of with the iconic stegosaur head?
Well, they're very small. And actually, stegosaurs are kind of famous. I think it's true that they have the smallest brain volume per unit of body mass of any terrestrial animal that's ever lived.
Wow.
So their brains are about the size of a walnut. They're very small. And these are animals that are 4, 5, 6 meters long, something like that. So yeah, they have very small heads and they have tiny teeth. Actually, only about 0.5 centimetre. The crowns of the teeth are only about 0.5 centimetre tall. So, I always thought this was probably suggested they were kind of slurping some soft material, soft pondweed or something like that. But actually, some of my colleagues have done some kind of bite force modelling and some engineering, using some engineering techniques to look at the strength of the skull. And we think actually they were, they could probably bite through twigs. They probably had the same bite force as a sheep. But maybe they had this sort of keratinous sheath kind of beak covering, which is actually quite common in these herbivorous dinosaurs. So it's almost a bit like a turtle's beak. And that they were using this to sort of crop vegetation.
So quite a strong beak, even with those small teeth. And do we have lots of Stegosaurus teeth surviving, or stegosaur teeth?
No, not really.
Oh,
and we've not got very many stegosaur skulls, actually. Mm-hmm. And not very many isolated teeth either. So we have a few skulls from North America and a few from China, which preserve teeth in the jaws. So we can see, where they fit and what they were like.
It's such a fascinating part of stegosaur's story, isn't it? The fact that this massive, bulky herbivore, like a bulldozer today, and yet, in comparison to the rest of its body, its brain size is the size of a pea.
Well, maybe a walnut. Let's not be unfair to it.
Sorry, okay, maybe I'm being... yes, you can tell me off if I'm being a bit too strict, but that's amazing.
Yeah, I guess, they did what they needed to do, which was to eat and mate, basically. And, that's what stuff needed to do. Make sure you don't get eaten. So, yeah, I was obviously smart enough to live for millions of years and be successful in its ecosystems.
And I'm guessing we don't know much about the eyes or the nose or anything like that.
No, it's quite difficult. Although we have casts of the inside of the brain case. So reptiles, the brain is encased in a kind of bony casing called the brain case. So we can CT scan a skull and we can look at that space that's, inside, which would have been occupied by the brain. And in meat-eating dinosaurs, people have done this, and you can see kind of big olfactory lobes, which relate to your sense of smell. So a big olfactory lobe might indicate very good sense of smell, or optic lobes, which might indicate a very good eyesight. But in the herbivorous dinosaurs, the ornithischian dinosaurs, we think that the brain probably didn't leave that quite as good impressions on the inside of the bones. So it's a little bit more hard to see those features in these sorts of dinosaurs. There's certainly nothing particularly remarkable when we look at that brain case, those endocasts as they're called. There's nothing that you go, wow, that was had amazing eyesight or anything like that. It just kind of looks kind of average, to be honest. So yeah, we don't have a good idea about its senses, really. Pretty much, I've told you about bite forces. I guess we know that it wasn't processing food. Stegosaurs didn't process food in their mouths. So we chew and we break down our food in our mouth and then we swallow. Lots of reptiles don't do that. They just swallow the food down, and then that digestive and processing takes place in the stomach. And birds, for example, will do this and then they eat stones, which help grind up food in their stomachs. Lots of the herbivorous dinosaurs actually evolved chewing like us, convergently to us, of course, separately from us. But the stegosaurs didn't. There's no evidence that they were, doing lots of kind of food processing in their mouths or anything like that.
Land a Viking longship on island shores, scramble over the dunes of ancient Egypt, and avoid the poisoner's cup in Renaissance Florence. Each week on Echoes of History, we uncover the epic stories that inspire Assassin's Creed. We're stepping into feudal Japan in our special series Chasing Shadows, where samurai warlords and shinobi spies teach us the tactics and skills needed not only to survive, but to conquer. Whether you're preparing for Assassin's Creed Shadows or fascinated by history and great stories, listen to Echoes of History, a Ubisoft podcast brought to you by History Hit. There are new episodes every week.
Well, let's go towards the body then. So should we be imagining a long neck or quite a thick neck, I guess?
Well, actually, different stegosaurs, there might be different answers for that.
Great.
We have Stegosaurus, which we know very well, which has a kind of totally average sized neck, I'd say. It's got to be able to reach the ground, otherwise it couldn't drink and eat. But yeah, it's not particularly long. It's not particularly notable. And then we have a dinosaur from Portugal, a stegosaur called Miragaia. And that actually has more neck vertebrae than most long-necked, long-tailed dinosaurs. It has 17 neck vertebrae, which is loads relative to most stegosaurs, which have between 11 and 13. So that one looks like it had a bit of a longer neck. So when we described that, we actually described that back in 2009 and named it, and we suggested that it was kind of mimicking a sauropod, a long-tailed dinosaur.
And do we think the primary purpose of that would be to reach higher up foliage, that idea?
Possibly. It's a bit difficult to tell. There's this idea that stegosaurs might have been able to rear up onto their hind limbs and use their tail as a kind of bit like a tripod. It's called the tripodal stance. And maybe this helped them reach higher into trees. So it's possible that they were doing something like that. And there's a little bit of evidence in terms of where their center of mass is that suggests they might be able to do that. So your center of mass is like, it's like the balance point of your body. So you can imagine it's like the balance point of a seesaw. And in stegosaurs, that seems to be over the hips, which means it would be quite easy for them to kind of push off and adopt that kind of position. It's a bit circumstantial. We don't really know whether they did it or not, of course. But yeah, they might have used it to reach higher into the trees.
We're talking about the legs. So my classic image of a Stegosaurus, from Cuddly Toys to shows like Walking with Dinosaurs and the like, is a big body and then stumpy legs. Is that the idea we have?
Yeah, well, all of these four-legged herbivorous dinosaurs, in fact, all the four-legged dinosaurs evolved from two-legged ancestors. So unlike with mammals, where often we see kind of, we as mammals evolved from four-legged ancestors, the mammals often have quite even length hind and forelimbs. Because the two-legged dinosaurs that were the ancestors of the four-legged ones had shorter forelimbs than hind limbs, what we see in a lot of the herbivorous dinosaurs, in the bird-hip dinosaurs, things like Stegosaurus and Triceratops and that, they actually have much shorter forelimbs than they do hind limbs. So I think, sometimes we put a very mammalian kind of view on what looks normal. And I suspect actually some of these dinosaurs would look quite weird to us. Very, very short forelimbs, quite crouched posture. So they couldn't straighten their forelimbs and they couldn't have I can't do this without miming. It's absolutely impossible to talk about dinosaur locomotion without miming. But they couldn't move their forelimbs forward and raise their arms in the air, if you like.
So almost this idea that a Stegosaurus in its natural pose potentially could be kind of leaning over a little bit because the front legs are a bit shorter than the hind legs.
Yeah, absolutely. So its back would have been angled downwards.
Interesting. So interesting. If we move up the body, we've got to talk about one of the two most iconic parts of stegosaurs, which are these plates. First off, what is the usual number of plates that we see on a stegosaur?
Well, this is an interesting question because stegosaurs are so rare as fossils, particularly complete individuals, that actually we didn't know the answer to that question until we got Sophie the Stegosaurus at the Natural History Museum, the Natural History Museum's one, because we had no stegosaur that preserved all the plates in the right place down the spine. But now Sophie at least has 19 plates and spikes down its back. So obviously we don't know whether that's typical for other stegosaurs. And there's a difference with Stegosaurus. Stegosaurus and some of its very close relatives seem to have plates that are offset. So they're not paired down the back. They're two rows of plates, but they're offset from one another. Whereas most other stegosaurs appear to have paired plates because we've actually got, although we haven't got the whole array, we've actually got plates from the left and right that are identical to each other.
So it's not just one line of plates along, which is also a classic image you get. There are multiple lines of plates.
Well, there's two lines, yeah.
Oh, sorry, there's
two rows of plates, yeah.
Right,
yeah.
That's so interesting. And so what are they made out of?
They are bone, which is why they preserve, why they fossilise. If they were soft tissue, they wouldn't fossilise. So that they have a bony core. However, when you look at them, they've got blood vessel channels running all over the surface. So it looks like they had a good blood supply. And they probably had some sort of keratinous covering. So this would be a material a bit like our fingernails, something like that, kind of a horny covering. So they would have been bigger than are preserved as bone. The bone would have been kind of the core of the plate, if you like.
And are they directly connected to the backbone, to the spine?
No, not at all. They're just embedded in the skin.
Interesting.
And this is similar to, actually, we see, they're called osteoderms, skin bone, right? So they're very, very hypertrophied. They're very elongated osteoderms. And we see these in alligators, actually, and crocodiles as well today. So they have them embedded in their skin and their backs. And actually all throughout the Mesozoic, throughout evolutionary history of lots of different groups of animal, we actually see osteoderms cropping up time and again. So it's not particularly unusual or unique to have bony bits in your skin. But what's interesting about the stegosaurs, and of course their close relatives, the ankylosaurs, is that they really took this to kind of extremes and really hypertrophied them and made them extremely elaborate and elongate and large and flashy.
Yeah, and absolutely extraordinary. And you said one of the most iconic images we have in our heads today, which leads to the big question. What do we think that these plates were used for?
Yeah, well, this is not a trivial question, actually, and not easy to answer because, actually being able to test ideas around the function of this, we call it armour, is really difficult. There's been a number of different suggestions of what the function might have been. I mean, I referred to it as armour, and, it could be armour. It could be for protection against predators. If you've got a load of spikes and plates sticking up off your back, Allosaurus isn't going to want to come down and take a big chunk out of your back.
I guess the fact, isn't it, you've got the carnivores of the time, which are, they can stand taller
yes.
than a stegosaurus.
Yes, they would have been taller. But of course, stegosaurus' flanks are entirely unarmoured. So it doesn't seem like great as a form of armour, I would have said. But, it would have put off the big ones from coming down on your back, presumably. You've then got ideas that they could be for display. So, often when we see in today's animals, features of the animals which don't seem to have any obvious function, look like they might be quite energetically expensive to produce. They often are related to some sort of display. Now, this could be to try to attract a mate, to show off, to try and attract a mate. It could be, think about a peacock's tail, for example. It could be for some sort of intraspecific combat. So if you think about the horns of an antler, the antlers of a deer even, or the horns of a bighorn sheep or something like that, they are, fighting each other for mates. It's usually something to do with mating. But, it could also be, we know that lots of these stegosaurs were living alongside each other in the same ecosystems. So it could be that, you're making sure you're mating with the right people. So it could be some sort of display function, not quite clear what that might be, but it could be a number of things. And then there's this idea of thermoregulation. So this is being able to control your body temperature. And of course, the closest living relatives today to the dinosaurs are the birds and the crocs. And if we want to understand features that aren't preserved in the fossil records, then we tend to look at the closest living relatives and say, well, what was the common ancestor of this animal doing? And metabolism is one of these, with these warm-blooded or cold-blooded animals. And actually, this is problematic because crocs are cold-blooded, they're ectothermic. Birds are warm-blooded. So we don't know what the common ancestor of crocs and birds was doing, and that we don't know what the dinosaurs were doing. We think that warm-bloodedness must have evolved somewhere on the line to birds, but where, we don't know. So we generally think, based on a few different lines of evidence, particularly how fast the stegosaurs were growing, they appear to be growing quite slowly relative to other dinosaurs, that maybe they had a relatively slow metabolism. They were more at the kind of cold-blooded end of the spectrum than the warm-blooded end. And thus, the problem for them, being massive multi-ton animals, was actually losing heat. So they would have generated lots of body heat from moving around and eating and digesting things. And how you get rid of that heat is difficult when you're a great big animal. So people have suggested that maybe the plates increased their surface area they would be able to flush hot blood into these plates and it would radiate heat out.
It's almost kind of like a ventilation kind of thing.
Yeah, or like a radiator. Yeah, absolutely.
Wow, and to cool themselves.
So the problem with all of these ideas, though, is actually how do you test them? It's really, really difficult, particularly given the fossil record that we have. So we might be able to test some ideas around display, for example, if we had a very large fossil record. We could say, well, do juvenile animals have really tiny plates and then they sort of grow really big and elaborate as they become adults? Because we know that features that juveniles tend not to have and adults tend to have tend to be something to do with sex, tend to be something to do with mating. Likewise, do we see differences in males and females? Now, we don't have any juvenile stegosaurs and we can't tell sex. We can't tell which are the males and which are the females. And we don't even have, we would need an enormous sample size. We would need hundreds of individuals to be able to tell, do one set have small plates and one set have big plates, for example, or different shape plates. And we simply don't have the sample size in stegosaurs to tell that. In fact, we don't really have it in any dinosaur, I would argue, to be able to tell that. So it's really difficult to test these ideas. And actually, I think it's a slightly made up question, really, because when we look at animals that are alive today that do have osteoderm, so things like crocs and alligators, what we know is they use them for loads of different reasons.
Yes.
So alligators use them to stiffen their spine. So it helps when they're walking on land, which they don't do that much. But when they do, it helps them stiffen their spine. They use them as calcium reservoir when they're making eggshell. And they actually do appear to use them for some parts of, for thermoregulating. So they actually use them to help lose heat. So I think it's very likely that stegosaurs might have used them for all of these different reasons. And actually, it's not really a debate about what they use them for. They probably use them for all of them.
Yes, and you can't take away the idea that, in a tricky situation, if it had to defend itself, it was still quite a good, piece of armour at the same time, wasn't it?
Yeah, absolutely.
But is it very much the fact that, the primary purpose of the plates of stegosaurs could well have differed depending on where in the world they lived and at what time in the Jurassic they lived?
Yeah, absolutely. And we do see really different armour in different types of stegosaur. So Stegosaurus from North America had very big, wide, flat plates. And as I said, they were offset from each other, whereas most other stegosaurs actually had much smaller armour and they were much more spine-like. So maybe not quite as good as heat radiators. Probably still would have had some, well, they definitely would have still had some function in, thermoregulation, but maybe not as great. But they might have been better as actual, protection. If you've got a big spike sticking out your back rather than a very thin plate, it might be more useful. I sometimes say that I think that Allosaurus could have chomped through Stegosaurus's plates like us eating Doritos, but I don't know whether that's true or not. But yeah.
But do some stegosaurs? We're going to get to the spiky tail very soon, I promise. Building up to it, but do some stegosaur types? Do they have spikes on their body as well instead of plates?
Yeah. So some, actually, quite a lot, we think, had shoulder spikes. So spikes, they again embedded in the skin, but over the shoulder blades. And then sticking out backwards. So there's one in China called Gigantspinosaurus. And as you might guess, it has a gigantic spine. It's about 1.5 meters long that sticks out from its shoulder region. And that one was actually, we know that they were shoulder spikes because that one, they were actually found in place alongside the arms. And lots of stegosaurs seem to have this. Stegosaurus doesn't. I think we've got several pretty good specimens of Stegosaurus. If they had them, I think we would have found them by now. There are some individuals of Stegosaurus that seem to have kind of throat armour. It's almost like chainmail, these little tiny ossicles, like little tiny, like beads almost of bone in the throat region. And we haven't found them in any other stegosaur, but we haven't got such a good fossil record of other stegosaurs, so it's possible that some of them did.
To protect that vulnerable area, maybe?
Well, yeah, it's a vulnerable area, isn't it? So.
Wow. And so, and the skin on the body of a stegosaur, generally, that's less armoured than the plates and the spikes?
Yeah, just scaly skin.
Just scaly skin. There we go. Well, then let's go on to the last part of the stegosaur, which is, of course, the tail region. And what is this other iconic part of a stegosaur that you have with the tail? So
stegosaurs have spikes at the end of their tail. Stegosaurus has 4. Some people refer to these as thagomisers.
That's the word I've seen.
Okay,
yes.
Well, so this word comes from a Far Side cartoon. And it is a caveman who is he's called Thag, and he meets his demise thanks to a stegosaur tail spike, so it becomes a thagomiser. And this, I have actually seen it being used in one scientific paper. I'm kind of against it, like it's used in the sort of dino nerd world. I'm against it on the basis that we have enough terminology in science. Like, we don't need any, I mean, they're just spikes. Let's just call them what they are, guys. Spikes. We don't need this.
Thagomizer.
Yeah, we
Sounds
don't
quite
need
cool.
it. And then people try and say, oh no, isn't the Thagomizer the whole? No, it's not. It's literally a made up word that was made up in a comic. It's nothing. It's not a thing. But anyway, yeah, so they're spikes at the end of the tail. And actually people have done some modelling to look at if the stegosaur swished its tail from side to side, like what would be the forces that would be generated at the end of the spikes. And we know that they would be pretty bone crushing. So, it could do Allosaurus's legs some damage, I think, if it was swinging its tail from side to side. So, yeah, probably a weapon.
Land a Viking longship on island shores, scramble over the dunes of ancient Egypt, and avoid the poisoner's cup in Renaissance Florence. Each week on Echoes of History, we uncover the epic stories that inspire Assassin's Creed. We're stepping into feudal Japan in our special series Chasing Shadows, where samurai warlords and shinobi spies teach us the tactics and skills needed not only to survive, but to conquer. Whether you're preparing for Assassin's Creed Shadows or fascinated by history and great stories, listen to Echoes of History, a Ubisoft podcast brought to you by History Hit. There are new episodes every week.
And the Stegosaurus has 4 of them.
Yeah.
But does the number of spikes on the tail differ between the other stegosaurs?
It seems to. We don't know. We haven't got complete articulated skeletons of other stegosaurs, but many of them seem to be much more spiky, as I said. And there's one called Kentrosaurus, for example, which is well known from Tanzania. And that seems to have spikes all the way up its tail.
Yes, Kentrosaurus is another interesting example. I had in my notes down here, but I wanted to mention it as well because, and that is another type of stegosaur, is it? It just looks a bit different than your classic Stegosaurus image.
Yeah, it's a different species. Yeah, I mean, it lived in Tanzania, so in Africa, but at the same time as Stegosaurus, roughly.
And is this idea like the swinging of the tail? Should we be imagining almost like kind of the big hip motions of today to generate that power, or is it more that the tail had more flexibility almost to kind of go almost to a right angle and then be swished that way, or is it the whole body bringing that kind of weight in an attack? Do we think?
The tail could flex side to side, not up and down so much, but side to side. So I think it would have swung its tail. But also remember, again, we do tend to have a very mammalian focused view of what things look like. And the tail of a dinosaur would have been much more like that of a croc. So they have these incredibly long muscles that run all the way along the tail. Very, very chunky, very robust. So very muscular. And those probably would have been used to swing the tail.
Got to ask because, I mean, if you haven't, I want to be there if you do it at any time. But have you guys at the NHM or have paleontologists tried to recreate a tailed swing, kind of get this idea of the body mass and then recreate some spikes and then have a dummy or something there, maybe like a piece of pork or whatever, a piece of meat, and to kind of test just how brutal a swing could have been? So
we have not done that, although my colleague, Heinrich Mallison, who was at the Museum für Naturkunde in Berlin, where Kentrosaurus is most of the fossils of Kentrosaurus are housed and is on display there. He has done it digitally. So he's done it computationally and calculated those forces at the end of the tail spike. And that's why we know that they could have kind of impacted bone, is because he's actually calculated the forces. So yeah, analog models are more difficult to come by, but doing it digitally is a little easier.
Come on, Susie, we got to make it happen. It's going to be hilarious. I'd love to see it. But that is kind of the classic anatomy of a Stegosaurus, isn't it? Of a Stegosaur. Is there anything we've missed that we should also mention about how its body functioned?
Oh, well, there's so much we don't know, really. So I don't think so. But, there's loads we don't know about the paleobiology of Stegosaurs because we just don't have that good a fossil record.
Well, it was also interesting what you mentioned there, that we don't have any juvenile Stegosaurs surviving. So do we not know much about young Stegosaurs or how they raised their young and the kind of when the plates developed and stuff like that?
Yeah, no, we know virtually nothing. I actually should say there is one juvenile that I'm aware of, at least, that was from Dinosaur National Monument in Utah in the US. And it's very incomplete. So it's just some hind limbs and some forelimbs and a little bit of pelvis. I don't think there's any plate. There might be one tiny plate, but it's very, very fragmentary. And that is the only baby stegosaur that we have. And as I say, very, very fragmentary remains. So very difficult to say anything about it. We don't have any nests. of stegosaurs. We don't have any eggs. Actually, I think probably we think now that for these sorts of dinosaurs, the bird-hipped dinosaurs, that primitively, that and stegosaurs are fairly early members of this group, that they were probably had soft-shelled eggs. So they weren't laying eggshells. They weren't laying eggs with calcite eggshells, and it's the calcite that preserves in the fossil record. So when we found dinosaur eggs, they tend to be they're calcite ones. Yeah, and that there has been some pretty recent discoveries of softer, kind of more leathery shelled eggs from some of these herbivorous dinosaurs. So I think that's probably a good explanation for why we don't have more nests or evidence of them. But even so, we might expect to have more young ones, but we don't. So we don't really know whether they were living in family groups. We don't know whether they were herding. We don't know whether they had kind of they sometimes call them nursery herds. This idea that maybe all the babies were living together and maybe a separate environment from the adults. We really don't have any clue about any of that.
When you read my next question, which was going to be like you imagine the big herds of Iguanodon, or even the sauropod herds, isn't it? It seems like Stegosaurus, that the question is still out there. But I guess also with their armour, I mean, do you see with like ankylosaurs later in the like that they are more individualistic, I guess, or more on their own?
Again, I don't think that we have a great answer to that. And I don't think that all of them, they might have been doing different things. So we have loads of different, ankylosaurs, there must be 60 or 70 of different types of ankylosaur. And it's possible that, different ones were doing different things. I think it seems quite likely that these dinosaurs were living in herds or, groups of some form, just because it's a really sensible way to defend yourself from predators. And I think we're very clear that these animals were not running very far. These are not fast-moving animals. They're not running away from predators. These big predators would have been slow-moving, and the herbivores would have been probably slower moving. So I think, there wasn't any pursuit predation going on. So they had to come up with different ways to defend themselves. And that could be why, one of the reasons why we see these very kind of elaborate structures on all these sorts of dinosaurs. So this armor in ankylosaurs and stegosaurs, and then we have things like the horns and frills in the ceratopsians, in the triceratops-like dinosaurs. So, it could be that they're using these kind of bizarre display or, possibly defensive structures to help defend themselves from predators because they can't run away. But I think, herding is kind of, it makes sense. We just don't have any evidence for it.
And talking about predators quickly, we've already mentioned Allosaurus, but do we think that there were any other kind of big predators that would have been the main, I guess, enemies, the main threats to stegosaurs?
Yeah, there are other big meat-eating dinosaurs around at the same time. So in North America, we've got Ceratosaurus, Marchosaurus, Torvosaurus living alongside them. Yeah, I mean, Allosaurus, certainly in North America, living alongside Stegosaurus, Allosaurus is by far the most abundant predator, by miles. The other meat-eating dinosaurs are much, much rarer. So really, the Morrison Formation, where these dinosaurs are found, where Stegosaurus and Allosaurus are found, Allosaurus ruled the Morrison. It was doing all the eating of everything, I think.
Well, I have in my notes one particular type of stegosaur that I know is close to your heart, that you've done work around, but please forgive me if I mispronounce the wording of it. Adraticlet bulafa.
Pretty good. I mean, I don't really... we named it in Amazigh, which is the language of the Berbers in the Middle Atlas Mountains in Morocco. And so I'm not going to pretend that I speak Amazigh either. So you can go nuts and pronounce it however you want. It doesn't mind.
I'm not going to try again,
okay.
But I'll say it once again. Adraticlet bulafa. So can you tell us about this particular stegosaur? This is a name I've never heard before.
Yeah, so this is a stegosaur that we named back in 2020, and it's from the Middle Atlas Mountains of Morocco. It was the first stegosaur found in North Africa, and it's from the Middle Jurassic. So it's really early on in the evolution of the stegosaurs. So when we first came across these fossils, which were actually for sale, they were for sale in a commercial fossil dealers in Cambridge, actually, and we spotted them, and my colleague at the Natural History Museum, is before I worked there, but he decided to acquire them for the museum, rescue them, if you like, from the commercial market and bring them into public ownership. And so we worked on these specimens. When you buy specimens on the commercial market like this, you often lose the contextual data that comes with them. So it said that they were from the Middle Jurassic of the Middle Atlas Mountains of this town called Balmain. But of course, we didn't know whether those rocks were accurately dated. We didn't know whether that information was correct. So I decided to go and try and find out where this specimen was from. And I went with a colleague who's a shark guy. He collects shark's teeth. And
Oh, we love fossil shark guys as well. Don't you worry.
Well,
So that's good to hear.
That's good. So he had been to Morocco a bunch of times because there's loads of sharks. You can collect shark's teeth in Morocco. And anyway, he knew all of the commercial dealers. And so he and I basically worked our way back down the commercial supply chain to the guy who dug the specimen out of the ground. And it was amazing. It was a farmer who lived on the side of a hill. And I showed him the picture of the specimen and he was able to just kind of take me to the hole and was like, this is where I got it from. And I worked with a geologist from the local university who is an expert in the rocks of the area. And so he was able to come with us and then say, yeah, this is all Middle Jurassic. This is this formation. These are these rocks, because he'd been working on these rocks for his entire career. And that was fantastic because we were able to demonstrate, exactly where the specimen was from, that it was indeed Middle Jurassic, making it one of the oldest stegosaurs we know in the world. And it's actually gone on to result in a really long-term collaboration between myself and the geologist and his group now. We've set up Morocco's first vertebrate paleontology labs at his university and doing lots and lots of work with them and training students there to be vertebrate paleontologists. So it's been an incredible project that started with a few stegosaur bones for sale in a fossil shop in Cambridge.
That's great. And to discover the first known stegosaurs in North Africa today, in the Atlas Mountains in Morocco.
Yeah, that's right. Yeah, and it's a very fragmentary specimen. I mean, we just have the forelimb, part of the forelimb, and some vertebrae, and that's it. So, we hope that we're going to find more there.
Do you think it's almost certain then that there are still so many different species of different types of stegosaurs from the Jurassic and maybe into the early Cretaceous that we just don't know about yet?
Yeah, definitely. Africa is virtually unsampled, relative to North America and Europe. We just haven't been looking there very long. And there's lots of, geopolitical and socio-political reasons why it's sometimes difficult. So they have Middle Jurassic rocks. It's a time period that I'm really interested in because it's when we really see, all of these different groups of dinosaurs get going and really radiate and diversify and sort of take over. Middle Jurassic rocks are present in places like Niger as well as Morocco, but it's difficult. It's dangerous.
Yeah.
The risk assessment that I would have to write would be so long to be able to work in some places that, we can't go there. Many places, as I say, Morocco had no vertebrate paleontologists working in the country in universities. So we set that up. So there are lots of reasons why these places aren't sampled.
And the African continent today, if going back into the Jurassic mindset, are we thinking the north of the emerging Atlantic Ocean or the south? Where should we be thinking?
Yeah, south. So southern hemisphere. Yeah.
And that's the area where there haven't been stegosaurs or known of until now.
Well, Kentrosaurus, which we mentioned earlier,
right,
that's from Tanzania. So that's been long known about. That was first discovered by the Germans in the early part of the 20th century. And there's also a little bit of material from Argentina. And it's quite cryptic in Argentina because the specimen was originally described not as a stegosaur, but as a kind of general early ornithischian bird-hipped dinosaur. The bird-hipped dinosaurs are part of the group that stegosaurs belong to. And actually myself and two other colleagues got the paper to review. So, when we publish a scientific paper, the first part of the process is you submit it to a journal and the journal goes, well, this looks interesting, but we're going to send it to some other experts to see what they think. And this is the process of peer review. We all do this to each other's papers. We all read each other's papers and comment on them. And it's part of, our job as scientists to review what other people have written and make comments on it. And I got this paper and I went, well, that's a stegosaur. And so did my two other colleagues. And we all sent our papers back independently of each other, of course, not knowing this, saying, well, we think these are stegosaurs. And the authors came back and said, we think it's a stegosaur too, but we keep doing these quantitative analyses that look at the evolutionary relationships of these different animals, and we can't make it be a stegosaur. It just doesn't want to be a stegosaur in our analyses. But anyway, subsequently we've shown that this animal is almost certainly a stegosaur. It looks exactly like a stegosaur. It's definitely a stegosaur. But it's very, very early. It's the world's oldest, so it's quite primitive, and that means it has a number of features that, kind of bridge the gap between some of these earlier dinosaurs and some later stegosaurs.
Well, it's really exciting having you on because, you're someone at the forefront of the developing story of stegosaurs and how, now in the 21st century, many of us growing up would have heard of Stegosaurus since we were kids and TV programs. But to think that actually more is being known about them, all the time, thanks to people like yourself and other papers writing about them and new discoveries being made. So it's a really exciting field for the future. I must ask, although, the evolution question, is it a fair question to ask what we think stegosaurs evolve into in the Cretaceous? Or do we think it just kind of dies out and then there's just a new type of armored dinosaur that comes to the fore?
Yeah, we don't. They went extinct,
Right.
so they don't evolve into anything. Our evolutionary trees, we make evolutionary trees. We reconstruct evolutionary relationships in kind of a semi-quantitative way, I will say. And yeah, the evidence from that is that they just go extinct.
Susie, this has been such a fun chat. Growing up, I've already mentioned the original series, Walking with Dinosaurs, as being a big influence. And I think it's been a big influence on so many of us, like at the end of the 1990s, beginning in the 2000s. And Stegosaurus' depiction there, I mean, what do you think of the depictions of Stegosaurus in the media world and their attempts to give us an idea of what Stegosaurus looks like?
I think generally they're very good. You would have to show me what Stegosaurus looked like in the original Walking with Dinosaurs. I can't remember what they did with it.
Quite like the classic with the big plates and the very small head.
Yeah.
And I think it's a fight against an Allosaurus in a narrow kind of ravine. And
I think, all of this is entirely plausible. I think the things that I see sometimes where I go, oh, that's a bit wrong, is when they make them run. So it's actually less common with Stegosaurus than you sometimes see with something like Triceratops, where you see them kind of galloping. And there was the recent Walking with Dinosaurs, they had Triceratopses running around, and I was like, no, they weren't doing any of that. There was no galloping around. This is ludicrous. But so that is one thing that gets my goat. But generally, I think they do pretty well with Stegosaurs. The thing with Stegosaurs is that we know so little about them that you've got a lot of latitude,
which makes them really fun.
Yeah.
And great as kids' toys and, from everything. And then in the media today. Susie, this has been absolutely great. We've covered so much, but is there anything else you'd like to mention about Stegosaurs before we finish?
Oh my God, I think I've told you everything I know.
Good. Well, I've done my job well then. It just goes to me to say thank you so much for taking the time to come on the show today.
Thanks for having me on.
Well, there you go. There was Dr. Susie Maidment talking all things Stegosaurus. I hope you enjoyed the episode. Thank you for listening. Please follow The Ancients on Spotify or wherever you get your podcasts. That really helps us, and you'll be doing us a big favour if you'd also be kind enough to leave us a rating. Well, we'd really appreciate that. Now, don't forget, you can also sign up to History Hit for hundreds of hours of original documentaries with a new release every week. Sign up at historyhit.com/subscribe. That's all from me. I'll see you in the next episode.